Welcome to The Explainer. Today, we're diving into something that is absolutely critical for keeping our apps snappy and responsive: asynchronous programming in JavaScript and TypeScript. We're going to trace the whole story, from a really frustrating problem to the super elegant solutions we all use today. So let's start with a situation you've definitely run into. You tell your app to go get some data from a server, right? And then, boom, everything just freezes. The whole user interface locks up, your buttons stop working, the app just feels totally broken. So why on earth does that happen?
Well, to figure that out, we're going to follow the exact journey developers took. First, we'll dig right into the root of this blocking problem. Then we'll look at the first attempted fix, callbacks. From there, we'll see how that evolved into something much cleaner with promises. And finally, we'll land on the modern, elegant solution that is the standard today. So let's get right to it.
To really get the solution, you have to understand the problem. And the problem is something at the very core of JavaScript. It's single-threaded. And all that really means is it can only do one thing at a time.
Think of it like a single line at a coffee shop. If one person at the front is taking forever to order, guess what? Nobody behind them can do anything. They're just stuck. In our code, a slow operation, like fetching a big file or waiting on a database, is that person holding up the entire line. It blocks everything else from happening.
And this is where asynchronous programming becomes our superhero. It's this technique that lets us basically say, hey, JavaScript, this next task, it's going to take a while, so go ahead and start it, but don't just stand there waiting. Move on, do other stuff, and just give me a shout when that long task is finally done.
So let's talk about the very first solution developers came up with to get out of that single file line, the callback function.
The big idea here is that a callback says, okay, go fetch the data, and when you finally have it, I want you to execute this specific function that I'm giving you right now. See? This is clever. It stops the whole program from freezing because it doesn't have to wait. It just passes along the instructions for what to do later on.
But this fix led to a brand new and very ugly problem. What happens when you need to do a few things in a row? Like fetch a user, then use that user's ID to fetch their posts, then use those posts to get the comments. Well, you get callbacks, nested inside of other callbacks, which are nested inside of other callbacks. This creates what developers call, and not very fondly, callback hell, or the pyramid of doom. And I mean, just look at that shape. It is a nightmare to read, a nightmare to debug. You get the picture.
So callback hell was a real problem. It was a sign that we needed a better way to handle this stuff. And that need led to the creation of a much cleaner, way more powerful solution: promises. A promise is basically an object that represents a future value. You can think of it like an IOU for data. You ask for something, and you immediately get this promise object back. It starts off in a pending state, and then, eventually, that IOU either gets fulfilled with the data you wanted, or it gets rejected because, well, something went wrong. And this is where the magic really happens. Instead of nesting our code deeper and deeper into that horrible pyramid, promises let us chain our actions one after another using .then. It creates this beautiful, flat, easy-to-read flow. It's like, first do this, then do that, then do this other thing. So much more logical. And if anything goes wrong anywhere in that chain, a single .catch at the very end can handle the error. Clean! Okay, so promises were a huge leap forward. But, you know, that syntax of chaining .then and .catch, it could still feel a little weird. So that brings us to the modern standard, something built right on top of promises to make things even better: async/await. Now, what's so cool about async await is that it doesn't actually replace promises. It's just what we call syntactic sugar. It's a much nicer way to write and work with them. Under the hood, it's all still promises doing the hard work, but our experience as developers is just dramatically better. And you can see it right here in this side-by-side. On the left, we've got the promise chain. It's good, it works. But now look at the right. It's the exact same logic, but with async/await. We just mark the function as async, and then we use the await keyword to pause and wait for our promise to finish. We can assign the result right to a variable, and we can handle errors with a totally normal try-catch block. It just looks like the simple synchronous code we all learned to write in the first place. It's so much cleaner.
So we've just seen how async await makes our functions way more modern. While we're on the topic, let's look at a few other awesome tools from TypeScript that can make all of our functions, asynchronous or not, way more flexible and a lot harder to break.
TypeScript gives us some really handy tools here. For instance, with an optional parameter, you can say, hey, this value might not be provided, and that's okay. Think of a middle name.
With the default parameter, you can provide a fallback value, like setting a default theme to light if the user hasn't picked one. And with REST parameters, you can write a function that takes any number of arguments, like adding tags to a blog post, and it just neatly bundles them all up into an array for you. These are all small things that just make our code so much more robust.
Whew! We've really traveled through the whole history of asynchronous JavaScript, haven't we? From a fundamental, annoying problem to a series of better and better solutions. So let's just do a quick recap of that whole journey.
This whole evolution, when you boil it down, has been about one thing: making our code easier for us humans to read. We started with callbacks, which worked, sure, but they gave us that unreadable pyramid of doom. Promises cleaned that up into a logical, flat chain. But the final step, async await, that was the real game changer. It gives us all the power of non-blocking code, but lets us write it in a simple, top-to-bottom style that's just natural for any developer to look at and immediately understand.
Honestly, understanding this journey, from a core problem to its modern solution, is absolutely key to writing effective professional code. It gives you the power to build applications that feel fast and responsive no matter how much heavy lifting they're doing in the background. So, the only question left is, how are you going to use this power?